Good day to you all there. I welcome you to this class once again. Today we'll be looking at the topic in mathematics, index notation and laws of indices. Index notation is a form of reducing the product of equal factors of numbers. Numbers that have equal factors, the method of reducing their numbers, their values, is called the index notation. Instead of us to write it in many ways, we have to make it to be little so that we can use a mathematical expression to express it. Now, for instance, if you have 3 multiplied by 3 times 3 times 3 times 3, how many times do I write this 3? 1, 2, 3, 4, 5. It will be equal to 3 raised power of 5. Instead of me to write all this one, I'll just write 3 raised power 5. It will be understandable by anybody that say this. Now, let's look at laws that govern indices. Laws of indices. The first law of indices is called the multiplication law. Multiplication law. If we have two equal factors, I have a power on them, and the powers that the factors are multiplied with one another, the value they are going to get will be that particular factor given to us, or the value given to us, raised to power the addition of the power on them. Check this out. If you have 5 raised power of 4 multiplied by 5 raised power of 3, this will be equal to 5 raised power of 4 plus 3. Whenever you see this multiplication here with two same values like this, what you do for their power on them is you add it together. This one will become 5 raised power of 7. Let's do the checking of this one now. We have 5 raised power 4 to be equal to 5 times 5 times 5 times 5. That was how many times? 1, 2, 3, 4. Multiply by this multiplication value there. 5 raised power 3 is 5 times 5 times 5. So this will be equal to 1, 2, 3, 4, 5, 6, 7. 5 raised power of 7. That is why we employ this index notation. Instead of us to continue writing it in several ways like this, or several times like this, we just write this 5 raised power 7. That is the value we are going to write there. Now we move to division law. Division law. If same number as well with power on them is divided by each other, the value on that power will be subtracted from one another. That is what that division law is trying to tell us now. So what we are having here is that if you have 4 raised power of 6 divided by 4 raised power of 2, you must make sure that those values that you are going to make this law to be applicable to must be of the same values. You can see this is 4, this is 4. If you introduce any other number there that is not 4, it cannot be applicable like that. So take note. So this will be equal to 4 raised power of 6 minus 2. That will be equal to 4 raised power of 4. Let's do the checking. 4 raised power of 6 will be 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5 times 4, 6. 4 raised power 2 is 4 times 4. So you can call this one call this. Call this one call this. We're having 1, 2, 3, 4. This is 4 raised power of 4. Now, the next particular information we're going to deal with is called the power law. That's number 3. Power law. In power law, we are talking about when you have some set of values inside a bracket. If you have a particular set of values inside a bracket, and there's that particular value inside a bracket is having power on it, and also is also having another value outside the bracket which is also a power, then that's what we call the power law. So we're having, when you have 3 raised power over 2 into bracket 4. This will be equal to 3 raised power. You just multiply this power with one another. 2 multiplied by 4, which is equal to 3 raised power of 8. Now, I think I'm communicating and we are understanding one another. That is how you do the application of the hammer like that. Now, this one simply means that 3 raised power of 2, that's 3 times 3, in 4 places. 3 times 3, 3 times 3, 3 times 3, 3 times. If you look at it, everything will be equal to 8 times. So that's why we have it 2 times 4 like that. So what you just do here is just you do the multiplication of those power with one another. Now the next one is called the product power law. Product power law. Product power law is applicable to when you have different values in a bracket and all of them in the bracket have a single power on them outside the bracket. So in that sense, each of them will have that power individually. If you have, for example, if you have 5 raised power 5 multiply 5xy raised power of 3, so this will be equal to 5 raised power of 3 multiplied by x raised power of 3 multiplied by y raised power of 3. Each of them will have a share of this power value that is outside like this. So take note of that one as well. Then the next one we have is called the zero index. Number 5 is zero index. In zero index, the information about zero index is just a clear one. It is a term that you must make sure that you take note of. Anything raised to the power of 0 is going to be equal to 1. Even if 10 billion uncountable values is raised to the power of 0 to be equal to 1. Now, we're going to prove it for you now. Okay, let's look at the 0 index. If you have 10 raised to the power of 0, it's equal to 1. If you have you have 3 raised to the power of 0, it's equal to 1. Now, what if you have 3 million? Raised to the power of 0 is equal to 1 as well. So now, let me quickly try to prove this for you. For instance, if I have a value like if I have like 3 raised to the power of 4 divided by 3 raised to the power of 4, you know, ordinarily, if I have this value like this, according to the division law I gave you the other time, you are going to subtract the power on them from one another because they are of the same value. So it's going to become 3 raised to the power 4 minus 4, which is going to be equal to 3 raised to the power 4 minus 4 is 0. So since 3 raised to the power 0, and that will be equal to what? That will be equal to 1, according to what I just said now. I want to prove it for you. It's equal to 1. Now, let me now prove it. 3 raised to the power 4 will be equal to 3 times 3 times 3 times 3. That's 1, 2, 3, 4 in 4 places. All over 3 raised to the power 4 again. 3 times 3 times 3 times 3 in 4 places again. If you can't start dividing it one after the other, 3 here 1, 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 3 here 1. 1 times 1 times 1, that will be equal to 1. You can see that when you have this one to be equal to 3 raised to the power 0 to be equal to 1, this one also is equal to 1. So anything you have been able to be proved that anything raised to the power of 0 will be equal to 1. Take note of that. Now, let's move on to another set of information which we call the negative index. In negative index, that's going to be number 6. If you have any number raised to the power of a negative value, the answer we're going to get for such a number will be the reciprocal of such number in the power of that positive of that value. Now, so what do I mean by that? If you have 5 raised to the power of minus 3, so this will be equal to 1 over, this is the reciprocal of 5 raised to the power of positive of this 3. Positive of this 3. So it is negative value of this 3 to become 5 raised to the power of positive of 3. So that is the what we mean by the negative index. So let's try to prove that now. Let's try to prove that one now. If you have 5 raised power of 2, 5 raised power 2 divided by 5 raised power of 5. 5 raised power 2 divided by 5 raised power of 5 will be equal to 5 raised power of 2 minus 5, which should be equal to 5 raised power of minus 3. So let's check this one very well. So if we want to check it now, we are going to have 5 times 5 all over 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5. So if I call this, I call this, I call this, I call this, I've got two of it. So it's remaining 1 over, how many 5 do you have here? 5 raised power of 3. You can see that that is provable. You have been able to prove that one right now. Now, the next one that we have there is called the root power. That's number 7. Root power. In mathematics, it is the root power is the forms of value that involve roots such as square root, it can be cube root, and it can as well be the fourth root. It can be cube root, fourth root. It can even be any forms of root that will be there. So if a particular information is raised to a particular fraction, the value you are going to have on them will be equal to the root, the particular denominator of such power will form the root of that value that we are talking about. For instance, if you have 7 raised power of 1 over 2, this will be equal to root of 7. If you have 8 raised power of 1 over 3, so this will be equal to cube root, because this is the denominator, cube root of 8. What is the cube root of 8? And this will be equal to like that. Now, this is how it is going to be done like that. And if it is fourth root too as well, whatever that is at the denominator of the power will be the one that will form the root for particular information you are writing. Then the next one is called the fraction index. Fraction index. Fraction index. When a particular value raised to a particular fraction, the value at the numerator will be a raised power, will still be at the power of such value, and the denominator one will now form the root of such a value. What do I mean by that? If you have 8 raised power of 2 over 3, this will be equal to, what is at the denominator? That's 3. Cube root of 8 raised power of 2. Very simple like that. That is what we refer to as a fraction index. All these set of information that we have, they are applicable into our different mathematical method of solving different solutions. So when we get to how to solve different solutions now, you'll be able to see how we will be applying all these forms of laws into those rules. They are useful almost in every part of mathematics. Laws of indices is very, very useful. So on this note, we are going to stop here. In our next class, we'll be dealing with different questions and how to solve them as regard the index notation and laws of indices. Thank you and stay blessed.